Okay, this video explains how to do assignment 5.2 geometric constraints. To begin, on School Loop, you need to open up the assignment you see on the screen here. When you open it up, you'll be able to work. To begin this, when you open this file up, the first thing you'll need to do is come over here to Sketch in your browser window. If you don't have your browser window open, say it's been closed and this is what you see, what you'll need to do is near the top of the ribbon here, go to the View command, switch your ribbon. Under User Interface, click on Browser. Once you have the browser up, then you'll be able to access this window and use this file. So in the browser window, you're going to double-click Sketch. When you do, the ribbon changes and you'll have some new commands up here. These are similar commands to when we were drawing our puzzle pieces. In here, this set of commands in the middle, the constrain area, contains the commands that we're going to use to work on this assignment. So what we'll be doing is looking for the appropriate command, and you can find that by hovering over any one of the commands. It will give you the name of that particular constraint and a brief description of what it does. To do this, we're going to start at the first box here, and its guidelines, it says make perpendicular. So the constraint command we're looking for is perpendicular. Luckily, these pictures up here are similar to what the command is. So this one that shows two lines perpendicular is in fact a perpendicular constraints. So when we click on that command and we come down and we click our two lines, it will make them perpendicular to each other. Now, it does make a difference in what order you do these. So if I undo this and I select perpendicular again and select them in a different order, you'll notice that the lines looked different. So pay attention as you do these to how the rules work for making these commands and these constraints. Now that these are perpendicular, no matter what I do to these two lines, in terms of anything else, hook other lines to them or dimension them or anything else, they will remain perpendicular to each other because that is the constraint, that's the rule that we've given these two lines. So let's move on to the next section. It says make all three lines parallel to one another. So we're going to look for parallel. Now this looks like parallel here, but it's not. It's an equal. So we're going to look for something else. Horizontal constraint? No, not quite. There we are, parallel constraint. So using the parallel constraint, we're going to click on that and then click on our lines to make these lines parallel to one another. Now these three lines will remain parallel to each other no matter what we do. We can change the distance they are from each other. We can change the length of these. We can hook other things to them, but they will remain parallel to one another. Moving on to the next spot. The next spot says dim number 3. So we want to dimension number 3 to a diameter of 2 inches. So we're going to use the dimension command this time. And when we dimension a circle, we're going to click on the circle and extend that leader line out to a spot that is convenient with the drawings around it and doesn't interfere with anything else. Click it again and we'll have that dimension. Now that's the dimension that it currently exists. To change the dimension of any line, in this particular case this circle, I want to double click on the dimension itself and we can change that dimension to the appropriate amount, in this case 2 inches, and it sets that size. Now it says to fix circles 1 and 2. Fix means to lock these in place. So we're going to use the lock up here to the fix constraint. Click on fix. To fix this circle, we can click on the circle or the center point of the circle. In this case, we'll click on the circle, and it includes the center point and circle of number 2. So 1 and 2 are now fixed in place. And then we're going to make number 3, circle number 3, tangent to 1 and 2. So we're going to use the tangent constraint up here. And then click our circles to make everything tangent to one another. Should end up looking like this when you're done. Sort of like Mickey Mouse upside down. Now next we're going to make the circle tangent to both lines. So we click our circle and tangent that to the side line and then the bottom line. You notice that it's changing its dimension along the way. Now we could change the angle of this and the size of that circle, but they would remain tangent to these two lines because that's the constraint that we've given it. These are important commands. Keep track of how these work. Later on, as you use these, they will be your decision as when to use these. All right, the next part says fix point C and make the endpoints A and B coincident with point C. Now point C is, we're going to call point C the center of the circle. That's what we're naming that, is that center of the circle, not the green dot next to point C. It's a little confusing, I realize, but the center of the circle. So we're going to fix point C, so using the fix command, fix the center of that circle, and then we're going to make the endpoints. The endpoints are the end of the line, not the middle of the line, which you can find as well, but the end of the line. And we're going to use the coincident constraint. So, going to the endpoint of A, I'm going to choose the top endpoint, and then the center of the circle, point C. It's going to fix that together. And the same thing with the endpoint of B. So that's the fixing the endpoints. Now, moving on to making the circles concentric. Using up at the top the concentric constraint. Concentric causes circles to have the same center point. So we're going to start with the outermost circle, go to the next size, and then add on to that the smallest circle, making somewhat of a bullseye look to these concentric circles. Make the lines collinear. Now collinear is different than parallel. These mean they're on the same line. So next to coincident constraint is the collinear constraint. Notice that coincident, the collinear, and concentric, all things sharing a similarity up here at the top. So by clicking each line with the coincident collinear constraint, we make them one line. We can see each of the individual lines by hovering over them. Notice they overlap each other a little bit as well, because we don't have any coincidence on the endpoints. They're just in line with each other. Further constraints on most of these would change what they look like some. Now we want to make our lines horizontal. So the horizontal constraint, we remember that, we ran across it looking for parallel, is this constraint here. And we're going to click on make horizontal. So both those lines are horizontal lines. Let's make some vertical lines with the vertical constraint. Vertical constraint up here. And then we click each of our lines. Now we're going to make an equilateral triangle. To make an equilateral triangle, first we have to understand what equilateral means, which means all of the sides are of equal size. We ran across the equal constraint when we were using our parallel. So it's similar parallel lines, it looks like an equal sign. So when we click our lines, those make those lines of the same size. And once we do all 3 lines, we will get a equilateral triangle. So now we're going to do make the circles the same size. And now the circles are the same size. One thing I want you to do that's not listed here though is to see now that they're all the same size. When I use the dimension to change the length of a particular side of my triangle. Let's make this a 2-inch triangle. It actually changes all of the sides to match that 2 inches because they are equal with each other. And the same with any other constraint we've put on there before. They remain consistent. So I'm going to change this dimension to 1.5 inches. I'll have 2 1.5-inch circles. Now we're going to line up the centers of the circles on the same horizontal plane. So to do that, we're going to use the collinear. Let's try the collinear to make these centers on the same line. Well, so that doesn't work. Same horizontal plane. Well, let's try horizontal. See if we can do that. Oh, there we go. Now they're on the same horizontal plane. All of them on the same line. So horizontal will do that for us as well. Any time that we make a mistake, we can always undo using the undo command or Control Z to go back and change what we've done. One of the things that can be handy is that we don't know necessarily what constraints are on any of these, but with a right click on our document, we can go to Show All Constraints, and then they pop up. So you can see that there's the perpendicular, the parallel lines, tangent lines, fixed locations, horizontal lines, equals. All of the constraints that we've just put in there are now listed on the diagram with our bits. When we don't need to see that anymore, we can right click and hide all constraints. Now that we're finished with this, we'll go ahead and finish sketch, and you save this and turn this in, Dropbox this assignment to School Loop now.